right, here we go. Question 24 from our Precalculus, homework number 11 in MyLab Math. We have a GeoGebra question. It says write an equation of a hyperbola given its graph. So we need to click the link to open the GeoGebra window. It says move point A and B to define a hyperbola, then write the equation of that hyperbola. And so we are able to move A and B. So it's important to notice that B can shift left or right, but it can't go up or down. A can go up or down, but notice as A moves left or right, it doesn't expand or contract the distance between. B does that. B expands the distance. So in order to make our life easier, it would be nice if we centered this hyperbola at the origin. And so what I'm going to do is I'm going to drop A down to the x-axis, and then I'm going to bring in B where the hyperbola is centered at the origin. The vertices are the same distance from the origin. The foci, A and B, are at 2 and -2. So this has nice symmetry. And so now what we need to do is go to our scratch work and make a couple of notes. All right, so what I've done is I've copied over the center, vertices, and foci into my scratch work. And then we're going to scroll up and determine which column of formulas to use. If I could draw your attention to the horizontal transverse axis, notice that the vertices and the foci have variable x coordinates, but the y coordinates are the same. And so that would fit the scenario that we have where the x coordinates of the vertices and foci vary, but the y coordinates, well, of the center, vertices, and foci, they're all 0. So this is a horizontal transverse axis. Notice that the center for either transverse axis is the ordered pair h, k. So from that we can determine that h is 0 and k is 0. If we scroll up and look at the formulas, notice that the vertices are h plus or minus a, k. So that would indicate that h plus a would be the larger of the x coordinates of the vertices, and h minus a would be the smaller of the x coordinates of the vertices. And we know h is 0. So if we replace h with 0, that's going to eliminate the h's, giving me that a is 1. And over here, if I change the signs, again, a is 1. And the only piece of the puzzle that I really need in order to find the equation is b. But I've got the foci, so we're going to have to find c, and then we can find b. So the foci are h plus or minus c, k. So h plus c should be the larger of the x coordinates of the foci. H minus c, the smaller. And again, h is 0. So if I replace h with 0, that's going to give me the value of c to be 2. If I know a and c, I can find b. Using the Pythagorean relationship that c squared equals a squared plus b squared, and doing a little plug and play. 2 squared equals 1 squared plus b squared. Moving the 1 over, that's going to make that 2 squared minus 1 squared, which is 4 minus 1, which is 3. And that is b squared. And don't square root because we actually need b squared. So now we know that a squared, which would be 1 squared, is 1. We know b squared. We know h and k. And so now if we scroll up, we can now plug and play into our equation for the hyperbola. All right, so that's going to give us x minus 0 squared over a squared minus y minus 0 squared over b squared equals 1. And then if we simplify x minus 0, that's just x squared over 1. I don't really have to write the fraction if I don't want to there. Minus y squared over 3 equals 1. And so this should be our final answer. Now let's go back to our GeoGebra window and see if we're right. All right, in our GeoGebra window, I have input the left-hand side of the equation equals the right-hand side of the equation, and we're going to check and see if we're right. And we're good. Please don't forget to click Save and Submit so that updates your progress in your MyLab Math. And that's going to do it for this problem. So if you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.